Assalamualaikum warahmatullahi wabarakatuh. I'm Azan Hakimi from Group 5. Today I'm going to give an explanation about the task have been given is about the crystal system. So before I'm going to further, I'm going to explain general explanation about the crystal structure. So crystal structure is a solid composed of atom, ion and molecule arranged in a 3D, three-dimensional. So crystal system have a crystal structure, space lattice, lattice point, and a unit cell of a structure. So crystal structure have three types of measure, which is face centicubic, body centicubic, hexagonal close pack. So we should calculate the atom packing factor. So later my friend will give a fully explanation about the crystal structure and the prototype also, including the calculation of atomic packing factor, which is total of sphere divided by the unit cell. That's all from me. Thank you. I'm Azan Hakimi from Group 5. Today I'm going to give an explanation about the task have been given is about the crystal system. So before I'm going to further, I'm going to explain general explanation about the crystal structure. So crystal structure is a solid composed of atom, ion and molecule arranged in a 3D, three-dimensional. So crystal system have a crystal structure, space lattice, lattice point, and a unit cell of a structure. So crystal structure have three types of measure, which is face centicubic, body centicubic, hexagonal close pack. So we should calculate the atom packing factor. So later my friend will give a fully explanation about the crystal structure and the prototype also, including the calculation of atomic packing factor, which is total of sphere divided by the unit cell. That's all from me. Thank you.
My name is Muhammad Amin Firdaus Abu Bakar. I'm from Group 5. So as you know, we have four lattice structure. For the first model is simple cubic. So for the how to create it, I will show you. Okay, for the simple cubic, as you know, it have four lattice point, which it share equally for 8 adjacent, means 1, 2, 3, 4, 5, 6, 7, 8. So that for the simple cubic.
Assalamualaikum warahmatullahi wabarakatuh. Commonly there are four common Bravais lattice structure, and I will show to you one of the Bravais lattice structure is FCC. For your knowledge, FCC has lattice point on each surface of the cube that give exactly 1/2 contribution, and it has a total of 4 lattice point per unit cell, with a coordination number of 12, and the face center cubic system is closely related to HCP, hexagonal close pack, but the only difference is in the relative placement of their hexagonal layer. So now I will show to you how to build this FCC. First, begin. Okay. this is FCC. Okay, the atomic packing factor, I will show to you how to calculate it. From the sectional view of the FCC, we get this. We will get this formula for R. R is radius of this piston, and square root 2 times A. From this we get R equals square root 2 over 4 times A. And for the atomic packing factor formula, Vs over Vc. Vs is an atom times V sphere, volume of sphere, and divide by A cube. We just put the value A into this cube. This is the volume of sphere. And this is total lattice point. So after we'll calculate it, we will get 0.74. This is the atomic packing factor for the FCC. Good morning. Today I'm the presenter for the group 5. And I'm going to present to you about metallic crystal structure. Commonly, there are 4 types of metallic crystal structure, and I will present to you one of the metallic crystal structure, and that is BCC. BCC is a body center cubic. Body center cubic has one lattice point in the center of the unit cell, and a total of 2 lattice points per unit cell, and has 8 coordination numbers. Its APF for the BCC, its atomic packing factor is I will show to you how to calculate the atomic packing factor. First, this is the formula, and an atom is the total of lattice point per unit cell, so it's 2, so we put 2. And the V atom is because the atom has a shape that look like a sphere, so we use a volume of sphere, so this is volume of sphere. And we just leave this unit cell, we just put this A cube. So after we calculate, we will get this 0.68. This is the atomic packing factor for the BCC, body center cubic. This is how to build a model of the BCC. First, we made the plasticine into 9 ball. All equipment that I use is a plasticine and a stick here. And then I will show to you the waist. So we make the base first from the plasticine, and then we make the upper layer. Okay, this is the upper layer of the BCC, and then we will make an atom in the center of the BCC. So this is the BCC center. We will combine it.
Okay, for our second lattice structure is HCP. As you can see, I will show you how to create it. So So this is our HCP model. As you can see, every unit cell have 6 number of atoms. So the total number of the coordination number is 12, which means the part A layers, I mean the top layer have 6 and the bottom layer have 6. So layers of sphere are packed so that sphere in alternating layer overlay one another. It's called as a closed pack because the A side, B side, and another A side. So means B side and A side, they overlay one another. Calculation APF for HCP, the formula is Vs over Vc, mean Vs is sphere volume over cell volume. Okay, the number of atoms for HCP is 6. So first we find the area triangle. The formula is 1 over 2 times A and times H. formula A is equal to 2R and H equal to square root A cube minus half A squared. So we will get 3 over 2 times A. After that, we find the area of base, which means we have 6 triangle for the base. So the area triangle that we calculate, we times 6. So we will get 3A squared times square root 3 over 2. So for the volume unit cell, VC, base area times C. For the formula C is, as you can see,